Hello everyone, this is Priya Chaturvedi and the topic of my today's presentation is pharmaceutical aerosols. So what are aerosols? Aerosols are basically the pressurized dosage form of the medicament which contain one or more therapeutic active ingredients which upon actuation emit a fine dispersion of liquid or solid material in a gaseous medium. Now coming to the advantages and disadvantages of aerosols. Advantages are that aerosols are very easily to withdraw. Aerosols are easy and convenient to apply. Faster onset of action. No manual or direct contact with the medicament. It avoids the first pass metabolism. A specific amount of dose or drug can be removed. No microorganisms can enter. The release of content is controlled and uniform. It protects the photosensitive medicaments and oxygen-sensitive materials. It provides efficacy of a drug and irritation can also be reduced. Now coming to the disadvantages, it is very much costly, difficult to dispose the empty aerosols containers, allergic in some cases, it is sometimes explosive also, and some formulations is very much difficult. Sometimes the propellant which are used can cause toxic reactions. Now, for aerosols, what are the desired characteristics needed? The aerosols which we prepare, it should be less explosive, it should be uniform and constant dose delivery, it should be non-allergic, economic, low cost, easy to handle, eco-friendly. Now coming to the components of aerosols. There are basically four types of components. First is the propellant, second is the container, third is the valve or actuator, and fourth is the product concentrate. As you can see in the figure also, these are the containers. The above we have the actuator. Actuator is basically the buttons which we press to come out the formulation. Valve, and then comes the propellant, and then comes the product concentrate. Now coming to propellant. What are propellants? Propellants are basically responsible for developing a proper pressure within the container. It provides a driving force. Expel the product from the container. Types of propellant. Propellant are basically of following types: liquefied gases propellants and compressed gases propellants. Now, propellants types. Depending on the route of administration and use, type 1 propellant, which is known as liquefied gas, it is basically divided into two types: for oral inhalation and for topical preparation. For oral inhalations, example is trichloro-monofluoromethane, which is also known as propellant 11. And second example is dichloromethane, which is also known as propellant 12. Second is topical pharmaceutical aerosols. Hydrocarbons, they are also known as hydrocarbons. Examples are propane and butane. Second type is type 2 propellant, which is known as compressed gas propellant. It is of following types. First is compound gases. Example is nitrogen and CO2. Now coming to the liquefied gas propellants. What are they? Actually, they exist as liquids under pressure. Because the aerosol is under pressure, the propellant exists mainly as a liquid, but it will also be available in gaseous form. The product is used up as the valve is opened and some of the liquid propellant turns to gas and it keeps the head space full of gases. In this way, the pressure in the can remains constant and the spray performance is maintained. Now coming to chlorofluorocarbons, propellants of choice for oral and inhalation. Advantages is it is chemically inert, lack of toxicity, it is non-flammable, lack of explosiveness. Disadvantage obviously first will be the cost and second is sometimes it depletes the ozone layer. Example is trichloro-monofluoromethane, which is also known as propellant 11. Second example is dichloro-difluoromethane, which is also known as propellant 12. And third example is dichloro-tetrafluoromethane, which is also known as propellant 114. Now coming to hydrocarbons. Hydrocarbons, it can be used for water-based aerosols and topical use. Advantages are inexpensive, they are excellent solvents, and it does not cause ozone depletion. Disadvantage is that inflammable and unknown toxicity is sometimes produced. Example is propane, isobutane, and butane. Now coming to next, compressed gas propellant. What are they? They occupy the head space above the liquid in the can, as you can see in the figure also. When the aerosol valve is opened, the gas pushes the liquid out of the can. The amount of gas in the head space remains the same, but it has more space, and as a result, the pressure will drop during the life of the can. The spray performance is maintained, however, by careful choice of the aerosol valve and the actuator used. Examples are CO2, nitrous oxide, nitrogen, etc. Now the containers. Containers which are used for making the aerosols, they must be able to withstand the pressure as high as 140 to 180 pounds per square inch gauge at 130 degree Fahrenheit. The aerosol containers which we basically use is of two types, metals and glasses. In metals like tin plated steels, aluminiums and stainless steel comes, and in glasses, uncoated glasses and plastic coated glasses come. Now coming to tin plated steel containers, what are they? It consists of a sheet of steel plate, and this sheet is coated by tin by electrolytic process. The coated sheet is cut into three pieces, top, bottom and body. The top bottom are attached to body by soldering process. When required, it is coated with organic material, which is mainly like phenol, vinyl, etc. The venting eliminates the soldering processes, and it saves the considerable manufacturing time, and it also decreases the product or container interaction. The recent developments in welding includes soldering systems and cono-weld systems. Now coming to next type of containers, which is known as aluminium containers. Aluminium containers, they are basically used for inhalation or topical aerosols. They are manufactured by extrusion process. They are light in weight, less fragile, less incompatible due to a seamless nature. Greater resistance to corrosion also. Pure water and pure ethanol can cause corrosion to aluminium containers. Next, coming to stainless steel containers. It is used for inhalation aerosols. Sample advantages is it is extremely strong, it is resistant to many materials, and there is no need of internal coating. Disadvantage is that it is very much costly. Now coming to glass containers. These containers are preferred because of its aesthetic value and absence of incompatibility. These containers are limited to the product having lower pressure like 30 psig and lower percentage of propellant. It is basically used for topical or meter dose inhalers aerosols. Two types of gas aerosols containers are used. First is uncoated glass containers, which is less cost and high clarity, and content can be viewed all the time. And second is the plastic coated glass containers. They are protected by plastic coating that prevents the glass from shattering in the events of breakage. Now coming to valve. As you can see in the figure, this is the portion of the aerosol in which we press and the product comes out. Valve, it is easy to open and close, and it is capable of delivering the content in the desired form, such as the spray, foam, or solid stream. It can also deliver a given amount of medicament. Now, top types of valve. First is the continuous spray valve, and second is the metering valve. This is the assembly of valve. As you can see, the upper portion is known as the orifice insert, and then comes the actuator. Then you can see the stem, gasket, and the valve cup, the spring cup, the spring, the valve housing, and the dip tube. Now coming to continuous spray valve. This continuous spray valve is basically used for topical aerosol. Valve's assembly consists of mounting cup, the valve body, stem, dip tube, gasket, and the spring. This mounting cup, it is used to attach the valve to the container. It is made from tin-plated steel, aluminium, or brass. The valve body, it is made up of nylon and it contains an opening of point of attachment of dip tube, which is about 0.013 to 0.080 inches. The stem, it is made from nylon or durlin, and sometimes brass and stainless steel can also be used. The orifice lies between 0.013 to 0.030 inches. Now the gasket. The gasket is made from neoprene rubber or Buna and spring. It is made from stainless steel and it is used to hold the gasket in the place. The dip tube, it is made from polyethylene or polypropylene. The inner diameter ranges from 0.120 to 0.125 inches. Now coming to metering valve. What are they? They are used to dispense the potent medication. They operate on the principle of chamber whose size determines the amount of medication dispensed. Approximately 50 to 150 mg of liquid material can be dispensed at one time when we use such valve. Now coming to actuators. These are specially designed buttons which help to deliver the drug in the desired form, that is spray, wet stream, foam, or solid stream. Now types of actuators. Actuators are basically of four types. First is the spray actuator, second is the foam actuator, third is the solid stream actuator, and fourth is the special actuator. Now coming to first, it can be used for topical preparations such as antiseptics, local anesthetics, and sprays. It allows the stream of product concentrate or the propellant to pass through various openings and dispense as a spray. Now coming to foam actuator, it consists of large orifice which ranges from 0.070 to 0.125 inches. Solid stream actuators. These actuators are required for dispensing semi-solid products such as ointment. Special actuators. They are used for specific purposes. It delivers the medicament to the appropriate site of action such as throat, nose, dental, and eyes. You can see spray actuators. Spray actuators are of different types. This is foam in the figure. Now coming to metered dose inhalers. Now, these are used to minimize the number of administration errors. They are used to improve the drug delivery of aerosol particles in the nasal passageways and the respiratory tract. Advantages of metered dose inhalers are it delivers a specific amount of dose, it is portable and compact, it is quick to use, no contamination of product, dose reproducibility is very much high. Disadvantages are low lung deposition, high pharyngeal deposition. Coordination of MDI actuation and patient inhalation is very much needed. As you can see in the figure also, this is metered dose inhaler. Now coming to pharmaceutical marketed aerosol products. These are the brand names like Advair. It consists of Aribobild, asthma, Bovar. It is used for asthma. These are all the examples of pharmaceutical marketed aerosol products. Now coming to the next topic, formulation of aerosols. Now the formulation of aerosols, it basically consists of two essential components. One is the product concentrate and second is the propellant. Now, what is product concentrate? The active ingredients or the mixture of active ingredients and other necessary agents such as the solvents, the antioxidants and the surfactants. They are the product concentrate. What are the propellants? They are the single or blend of various propellants used. Blend of solvent is also used to achieve the desired solubility characteristics. The surfactants are mixed to give the proper HLP value for the emulsion system. The propellants are selected to give the desired vapor pressure, solubility, and the particle size. The pharmaceutical aerosols may be dispensed as fine mist, wet spray, stable foams, semi-solid, breaking foam, etc. Type of systems selected depends on physical, chemical, pharmacological properties of drugs and the site of application. Now coming to the types of systems. There are following types of systems in aerosols. First is the solution system. Second is the water-based system. Third is the suspension or dispersion system. Fourth is the foam system. And fifth is the intranasal system. Now coming to first type of system, which is known as the solution system. Now solution system, what is this? This system is also referred to as a two-phase system, which consists of a vapor and the liquid phase. If active ingredient is soluble in propellant, no other solvent is required. The vapor pressure of the system is reduced by addition of less volatile solvents such as the ethanol, acetone, propylene glycol, glycerine, ethyl acetate. This results in production of larger particles upon spraying. The amount of propellant may vary from 5% to 95%. The general formula is active drug, which can be 10 to 15%, and the propellant can be 100%. Okay. Next is, these are the different types of formulations. Depending on the water content, the final product may be solutions or a three-phase system. Solution aerosol produces a very fine two-course spray. The hydrocarbon propellant, it produces drier particles, while the propellant A17 and A31 tends to produce a wetter spray. These are useful for topical preparation. They are packed in plastic-coated glass containers. Now coming to water-based system. Large amount of water can be used to replace all or part of the non-aqueous solvents which are used in the aerosol. They produce spray or foam. To produce a spray, formulations must consist of dispersions of active ingredients and other solvents in emulsion system in which the propellant is in the external phase. Since propellants and water are not miscible, a three-phase aerosol forms. Ethanol can also be used as a co-solvent to solubilize propellant in water. It also reduces surface tension, which helps in production of smaller particles. 0.5 to 2% of surfactants is basically used to form a homogeneous dispersion. Surfactants with low water solubility and high solubility in polar solvents can be useful. Examples are long-chain fatty acid esters, stearic, lauric acid, etc. Propellant concentration varies from 25 to 60%. The aquasol system, it is the dispensing fine mist or the spray of active ingredients which are dissolved in water. No chilling effect since only active ingredient and water are dispensed. Propellant is in vapor state. Difference between aquasol system and three-phase system is that aquasol dispenses fairly dry spray with very small particles, non-flammability of the product. Now coming to suspension system. It involves dispersion of active ingredients in the propellants or the mixture of propellants. To decrease the rate of settling of dispersed particles, surfactants or suspending agents can be added. Primarily, it is used for inhalation aerosol. Physical stability of aerosol dispersion can be increased by control of moisture content, reduction of initial particle size to 5 micrometer, adjustment of density of propellant and suspensions, use of dispersing agents, use of derivatives of active ingredients with minimum solubility in the propellant system. Physical stability of a dispersed system, it depends on the rate of agglomeration of the suspension. Agglomeration is accelerated at elevated temperature, and it can also affect the particle size of the drug. Agglomeration results in clogging, inaccuracy of doses. Depending on the nature of active ingredient, it sometimes causes damage to the container also. Isopropyl myristate and mineral oil are used to reduce the agglomeration. Surfactants of HLB value less than 10 are utilized for aerosol dispersion. Foam system. Emulsions and foam aerosols, they consist of active ingredients and aqueous and non-aqueous vehicles. Surfactants, propellants are dispensed as a stable or quick breaking form depending on the nature of active ingredients and the formulation. Total propellant content is usually 3 or 5% weight by weight or 8 to 10% volume by volume. As the amount of propellant increases, the drier foam is produced and the stiffer foam is also produced. Lower propellant concentrate yields better foam. Hydrocarbons and compressed gas propellants are basically used. Thermal foams. It is used to produce warm foam for shaving. It is used to dispense hair colors, dyes, but were unsuccessful due to corrosion problems and are expensive, inconvenient to use, and lack of effectiveness. Intranasal aerosols, intended to deposit medications into nasal passage for local or systemic effect. Advantages are it delivers the measured dose of drug. It requires lower dose compared to other systemic products. Excellent depth of penetration in the nasal passageway is produced. Decreased mucosal irritability, maintenance of sterility from dose to dose, and greater flexibility in the product formulation is achieved. Now you can see this is the empty can. We add the product, then we fit the valve, then we add the propellant, and then we fit the actuator. Now, manufacture of pharmaceutical aerosols. There are 3 steps. First is the pressure filling apparatus. Second is the cold filling apparatus. And third is the compressed gas filling apparatus. Coming to first, pressure filling apparatus. It consists of a pressure burette which is capable of metering small volumes of liquefied gas into the aerosol containers under pressure. The propellant is added through an inlet valve which is located at the bottom or top of the pressure burette. The propellant is allowed to flow with its own vapor pressure in the container through aerosol valve. The trapped air escapes out from the upper valve. The propellant then stops flowing when the pressure of the burette and the container becomes equal. If further propellant is to be added, a rubber pipe leading to a cylinder of nitrogen is attached to the upper valve, and the pressure exerted by the nitrogen, it helps in the flow of the propellant into the container. Another pressure filling device makes use of piston arrangement, and it is capable of maintaining a positive pressure. This type of device cannot be used for filling inhalation aerosols which have a metered valve. Now, what is the procedure? Procedure is, this method involves filling of the concentrate into the container at the room temperature. Then the valve is placed into the container and it is crimped. Through the opening of the valve, the propellant are added and it can be added under the cap. Since the opening of the valve is smaller in size, which ranges from 0.018 to 0.030 inches, it limits the production and the process becomes very much slow. But with the use of rotary filling machines and newer filling heads where the propellants are filled to the valve stem, the production rate is increased. The trapped air in the container and the air present in the head space is removed before filling the propellant to protect the product from getting adversely affected. Various units used in the pressure filling lines are arranged in the following order. Like you can see the order, first is unscrambler, then air cleaner, then the concentrate filler, then the valve placer, then the purger, then the valve crimper, then the propellant filler, then water bath, leveler, odor, and packing table. Now, what is the advantages of pressure filling? The solutions, the emulsions, the suspensions can be filled by this method as chilling does not occur. Contamination due to moisture is less. High production speed can be achieved. Loss of propellant is less. Disadvantages: certain types of metering valve can be handled only by cold filling process or through use of a under the cap filler or valve crimper. Process is slower than cold filling method. This is the pressure filling equipment. You can see. Now coming to the next, cold filling apparatus. It consists of an insulated box which is fitted with a copper tubing, and the tubing are coiled to increase the area exposed to cooling. The insulated box should be filled with dry ice or acetone prior to the use. The apparatus can be operated with or without metering valve. The hydrocarbon propellant cannot be filled into the aerosol container using this apparatus because large amount of propellant escapes out and vaporizes. This may lead to the formation of an explosive mixture. Fluorocarbon vapors do not form an explosive or flammable mixture, though their vapors are heavier than air. Now, what is the procedure? The non-aqueous product or products which can withstand low pressure of -40°F are used in this method. The product concentrate is chilled to a temperature of -40°F and filled into already chilled container. Then the chilled propellant is added completely in one or two stages depending on the amount. Another method is to chill both the product concentrate and the propellant in a separate pressure vessel to -40°F and then filling them into the container. The valve is placed and crimped onto the container. Then test for leakage and strength of the container is carried out by passing the container into a heated water bath where the contents of the container are heated to 130°F. After this, the container are air dried, capped and labeled. Various units which are used in cold filling methods are unscrambler, air cleaner, concentrate filler, propellant filler, valve placer, valve crimper, water bath, labeler coder, packing tables. The cold filling method is no longer being used as it has been replaced by pressure filling method. Advantages are easy process. Disadvantages are the aqueous products, the emulsions, and those products which adversely affected by cold temperature cannot be filled by this method. This is the whole assembly of cold filling apparatus. Now coming to compressed gas filling apparatus. The compressed gases have high pressure, hence a high pressure reducing valve is required. The apparatus consists of delivery gauge, a flexible hose pipe which can withstand 150 pounds per square inch gauge. Pressure is attached to the delivery gauge along with the filling head. A flow indicator is also present in the specialized equipment. Procedure: the product concentrate is filled into the container. Valve is placed and crimped onto the container. With the help of the vacuum pump, the air is removed from the container. The filling head is put in the opening of the valve and the valve is depressed and the gas is allowed to flow into the container. The gas stops flowing if the delivery pressure and the pressure within the container becomes equal. Carbon dioxide and nitrous oxide is used if more amount of gas is required. High solubility of gas in the product can be achieved by shaking the container manually or with the help of a mechanical shaker. Now coming to the quality control test. It includes the testing of propellant, valve, actuator, dip tubes, containers, weight checking, leak testing, spray testing. Now propellants. Vapor pressure and density of the propellants are determined and compared with specification sheets. Like parameters are identification which are tested by gas chromatography, IR spectroscopy. Purity and acceptability are the moisture, halogen, non-volatile residues, determinations, etc. Valve, actuator and dip tubes. Sampling is done according to the standard procedures for metered dose aerosol valves. The test methods which were developed by Aerosol Specification Committee, the Industrial Pharmaceutical Technology Section, the Academy of Pharmaceutical Sciences, they are used. The objective of this test is to determine the magnitude of valve delivery and the degree of uniformity between the individual valves. The standard test solutions were proposed to rule out the variations in the valve delivery. These are the test solutions and these are the solutions for A, B and ingredients and A, B and testing procedures are carried out by taking 25 valves and they are placed onto the containers and they are filled with the specific test solutions. Actuators with 0.020 inch orifice is also attached. temperature is minus 25 degree plus minus 1 degree centigrade. Valve is actuated to the fullest extent for 2 seconds and wait. Again, the valve is actuated for 2 seconds and wait. The difference between them represents the delivery in mg, and this is repeated for 2 individual deliveries for each for 25 test units. And then by this formula, the individual delivery weight in mg upon specific gravity of test solutions, we tested and we calculated, and the value which is accepted is 54 microliter or less, then plus minus 15% is the limits, and 55 to 200 microliter plus minus 10% is the limit. Of the 50 individual deliveries, if 4 or more are outside the limits, valves are rejected. If the 3 deliveries are outside the limit and the 25 valves are tested, lot is rejected if more than 1 delivery is outside the specification. If 2 delivery from 1 valve are beyond the limit, another 25 valves are tested, and lots is rejected if more than 1 delivery is outside the specification. For containers are examined for detecting in the lining. Quality control aspects include degree of conductivity of electric current as measure of exposed metal. Glass containers examines for flaws are done. Weight checking. It is done periodically, adding to the filling line tarred empty aerosol containers, which after filling with concentrate are removed and weighed. Same procedure is used for checking weight of the propellant which are being added. Leak testing. It is a mean of checking crimping of the valve and detect the defectiveness of the containers due to leakage. It is done by measuring the crimp's dimensions and comparing. Final testing of the valve closure is done by passing the filled container through the water bath. Spray testing. Most pharmaceutical aerosols are 100% spray tested. This serves to clear the dip tube of pure propellant and pure concentrate, to check for defects in valve and spray pattern. Now coming to evaluation test. Flammability and compensability. Now flash point, flame point, projections. Physicochemical characteristics may we have 4 parameters: vapor pressure, density, moisture content, identification of propellant. Performance, we have 6 parameters: aerosol valve discharge rate, spray pattern, doses with metered valve, net contents, foam stability, particle size determination. Biological testing, we have 2 parameters: therapeutic activity and toxicity study. Now coming to flammability and compensability. Flash point, the apparatus which is used is tag open cup apparatus. Product is chilled to minus 25 degree 10 centigrade Fahrenheit, and the test liquid temperature is allowed to increase slowly, and the temperature at which vapors ignite is called the flash point. Now flame projection. Product is sprayed for 4 seconds into a flame, and the flame is extended. Exact length is measured with a ruler. Physicochemical characteristics. Vapor pressure, pressure gauge is used for density, hydrometer is used, or picnometer is used for moisture, Carl-Fisher method is used, or gas chromatography is used. Identification of propellants, gas chromatography or IR spectroscopy is used. Performance test. Aerosol valve discharge rate. The content of the aerosol product of the known weight is discharged for a specific period of time. By reweighing the container after the time limit, the change in the weight per time dispensed gives the discharge rate. Spray pattern. This method is based on the spray on the piece of paper that has been treated with dye talc mixture. The particle that strikes the paper causes the dye to go into the solution and to be absorbed on the paper, giving a record of spray for comparison purpose. Doses with metered valve. Reproducibility of doses can be determined by assay technique, accurate weighing of filled containers. Net content. The tarred cans that have been placed onto the filling lines are reweighed, and the differences in weight is equal to the net content. Foam stability. Visual evaluation is done. Time for given mass to penetrate the foam is done. Now, rotational viscometer is sometimes also used. Particle size determination, cascade impactor is sometimes used, or light scattering decay is used. cascade impactor. What is this? This basically, the principle is the stream of particles is projected through a series of nozzles and the glass slides at high velocity. The larger particles are impacted first on the lower velocity stage, and the smaller particles are collected at the higher velocity stage. And second is the light scattering decay. Principle is as aerosol settles under turbulent conditions, the change in the light intensity of a tindal beam is measured. Biological testing, therapeutic activity. For inhalation aerosols, doses of the product is determined and is related to the particle size distribution. For topical aerosols, it is applied to test the area and absorption of therapeutic ingredients. Toxicity. For inhalation aerosols, exposing the test animal to vapor sprayed from the aerosol containers. For topical aerosols, irritation and chilling effects are determined. Thank you.